class. Today we want to talk about, continue our discussion of subatomic particles, and we want to talk about what's called leptons. So we'll get into that in a moment. To begin with, I just want to talk about the strong force and the weak force. There's four fundamental forces. I think I've mentioned this in class. The strong force, the weak force, the gravitational force, and the electromagnetic force. And we know how gravity works. If you drop an object, the attraction between two masses will pull an object, let's say, down to the mass of the Earth. And we've spoken about the electromagnetic force. That's basically like charges repel, opposite charges attract. When we had a balloon and we got that balloon to stick to my hair, that was electromagnetic force. And when we watched that video, You Can't Touch Anything, where we said when you sit in a chair, the electrons in your butt and the electrons in the chair repel each other, and so you end up sitting on the chair, and that's because of the electromagnetic force. So we've spoken a fair amount about the electromagnetic force and the gravitational force. We haven't spoken too much about the other two forces, the strong force and the weak force. So I just want to say, let's just talk about the strong force. The strong force binds quarks together in clusters to make more familiar subatomic particles such as protons and neutrons. It also holds together the atomic nucleus and underlies interactions between all particles containing quarks. So last time we spoke about quarks, and we said that two up quarks and a down quark will make up a proton, and two down quarks and an up quark will make up a neutron, and those neutrons and protons are located in the center of each atom. Well, what holds these quarks together? And that is the strong force. Okay, so this strong force holds the quarks together to form protons and neutrons, and even holds all the protons together and neutrons together in a bunch to form the nucleus as a whole. Okay, so the strong nuclear force is an attractive force between protons and neutrons. It keeps the nucleus together. And we're not going to talk a whole lot about the weak force, but just to throw it in here, the weak force is responsible for radioactive decay. And it was realized that these two forces, which both are forces that are responsible for keeping an atom together or behaviors of atoms, but there was a realization from experimentation that these two forces were not equally strong. One had a much larger strength and the other one was weaker. And the strong force, which holds the nucleus together, was a stronger force, and that's why they call it the strong force. And the other force, which is responsible for radioactive decay, was a weaker force, and so they call it the weak nuclear force. So these are just our last two forces. But the strong nuclear force holds quarks together to form protons and neutrons and to hold the nucleus together all together. All right, so just make an association. Strong force goes with the nucleus and quarks, holding quarks together. All right, but we don't just have, there's two broad categories of particles. One is going to be quarks, and the other is leptons. And leptons are things that are not affected by the strong nuclear force. So leptons are things like electrons and neutrinos, and we're going to talk a little bit about neutrinos in a second. So just two broad categories of particles: quarks, which interact through the strong force, and leptons are subatomic particles that do not interact through the strong force. Okay, quarks we're going to see in the nucleus, they interact through the strong force. Leptons do not interact through the strong force. Okay, two broad categories of subatomic particles. All right, and let's talk about these leptons. And we want to just talk about two leptons here: the electron and the neutrino. Okay, so these are just two leptons. Okay, the electron is charged. We know a lot about the electron. We've spoken about the electron. Electron is what flows when electricity flows in a wire, that is moving electrons. So we've spoken a fair amount about electrons, but the neutrino we haven't spoken a lot about. And a neutrino is a neutral particle. It does not have any charge on it. Another thing about leptons is that they don't combine to form other particles the way quarks do, right? Quarks, you can take 3 quarks together and you can make a proton. 3 quarks, you can make a neutron. Leptons don't combine to form larger particles, okay? So a lepton is a particle that does not undergo strong interactions. It does not utilize the strong force. And leptons also do not combine to form larger particles. Of our the 2 leptons that we want to talk about today, electrons, we know we've spoken about electrons in the past. We manipulate the flow of electrons as we use electricity. So every time we turn on a light bulb, electrons are flowing. But the neutrino is different. We don't talk about the neutrino very much. The neutrino has no charge. It's very small. The electron is small, but the neutrino is even much smaller than an electron. So this is a extremely small particle, much smaller than electrons. And they're so small, and they don't have any charge, so they're not going to be attracted to electrons. They're not going to be attracted to protons. And millions of neutrinos will pass right through our body every second. So that's how small they are. They're so small they pass right through atoms. They pass right in through the empty space in atoms. They really, since they have no charge on them, they don't get deflected by the electrons. They don't get deflected by the protons. They just kind of move right through our bodies. So it's very difficult for us to not only use neutrinos, right? We use electrons. We use electrons to power our light bulbs and our television sets. We don't, not only do we not use neutrinos in a practical way yet, but it's also very difficult for us to even detect neutrinos. So it's very hard for us to even though millions of these neutrinos are passing through our body every second, it's very hard for us to even sense them using any kind of an instrument or measure them in any way. They're so small, and they don't interact with charged objects. So I've attached a couple of videos that I think are a little bit interesting. There is a neutrino detector that was built on the South Pole. It's so hard to detect these neutrinos that they have built this detector on the South Pole, and they use a big cube of ice. Apparently the ice in the South Pole is very pure, and they take really almost a mile of ice down, a mile of ice across, and a mile of ice deep. So think of an ice cube that's about a mile high, a mile long, and a mile wide. And they put these sensors inside that big chunk of ice on the South Pole, and they're using that to detect high-energy neutrinos coming in from outer space. And even with this very large detector, and with so many neutrinos coming through this chunk of ice, they only get a few detections per year. So it's very hard for us to sense and detect these neutrinos at all. But take a look at the video, and just you'll get a sense of how small neutrinos are and how they really don't interact with matter very much. So it's very hard for us to detect them. If when you're watching the video you see any reference to the Standard Model, don't worry about that. We're going to talk about that next time. But for now, I just wanted you to understand that as we talk about these subatomic particles, there's 2 broad categories: quarks that make up the protons and neutrons, and leptons, which do not respond to the strong force. And 2 leptons that I'd like you to know about are the electron and the neutrino. We've spoken a lot about electrons. Throughout the year, we've spoken a lot about electrons. So I just want to highlight today the other lepton, which is the neutrino, and indicate that it's got no charge and it's super small and it's really hard to detect. And when you watch the videos, you'll see what great lengths we have to go to try to detect neutrinos. All right, so just take a look at the videos and then answer the questions in the attached form. Thank you.